Hello and welcome to our lesson on formula. This is part of our Functional Skills Maths course at levels 1 and 2. Believe it or not, this is actually a formula for happiness. There are two learning outcomes for this video, only because it's split between levels 1 and 2. If you're level 2, you need to understand the level 1 method, and if you're level 1, sooner or later, you're going to need to understand the level 2 method. So we'll cover both of the methods within this video. So the level 1 outcome is to use simple formula expressed in words for one or two-step operations. The level 2 outcome is to evaluate expressions and make substitutions in given formula. Our linked learning goes back to when we were doing the word type questions for addition, subtraction, multiplication and division. Without realizing it, you've actually been solving formula. For example, in one of the earlier lessons, you could quite easily have come across a question like this. A call to the United States costs £2 a minute. If I make a 7-minute phone call to the USA, how much will it cost? In previous lessons, you would have taken the £2, multiplied it by the 7 minutes to give us £14 for the total cost of our calls. But what you might not realise is that this is part of a formula, and until you're given the number of minutes, it's 2 times the number of minutes. And what you're doing is you're swapping the minutes for the number 7 to solve this formula. So you've actually been using formula without realizing it. So our definition for a formula is that it is a rule or a relationship. So for example, if we say that Sam is paid £5 per hour, we've created a formula. There's a relationship between Sam's pay and how long he works. So his pay is equal to £5 multiplied by every hour he works. This is a rule or a relationship. Now, it's a formula because we can't do anything with it until such time as you tell me how many hours Sam has actually worked. So if I tell you that he worked a 10-hour shift yesterday, then we can say that 5 times 10 is going to give his pay. So his pay is £50 because we swapped the 10 hours he worked for the number of hours in the formula. Again, questions like this is what you would be given in a wordy type question to get you to multiply, where the cost of hiring a cement mixer is £30 for every day. So I can't do anything with it until you tell me how many days I'm going to look at. So in theory, you've created a formula. You've got a cost, and you know that it's equal to 30 times the number of days. And until I tell you the number of days, you can't do much with it. And this is something you would have come across many times, but not realized you're actually using formula. So if I say to you, I want to hire the cement mixer for 6 days, then you swap the word day for the number 6. So 30 times 6 tells me my cost is going to be £180. So this is a basic one function formula where you're going to times 30 by something and you can't do anything with it until somebody tells you what it is. Let's have a look at another wordy type formula question that you get that isn't too complicated, but it's been simplified for you by breaking it down into these boxes, sometimes known as the flowchart method. So a piece of ham takes 30 minutes per kilogram to cook, plus an extra 25 minutes. So whatever the weight is of my ham in kilograms, I have to multiply it by 30 and then add 25. So this is a formula. And until somebody actually tells me how much my ham weighs, I can't do much with it. But once I tell you how much the ham weighs, you can put it into this formula or flow diagram and get your answer out. So I'm going to tell you that my ham weighs 5 kilograms. So it tells you the order to do things. So the first thing to do is multiply it by 30. So that gives me 150 minutes. But then we need to add 25, and that gives us 175 minutes as the cooking time. Can you see what we did there? So this is a formula. I can't do anything with it until somebody gives me something to put in at this end, which in this case I gave you 5. So 5 times 30 gave me 150. Then don't forget to add the 25. Tells me I need to cook my ham for 175 minutes. Let's have a look at another flow diagram. In this one, Carrie is checking her electricity bill. To work out how much her electricity cost, she uses this rule. She takes the number of units, multiplies by 3, adds 15, and this gives her the cost of the electricity in pounds. So Carrie's used 50 units of electricity so far this year. How much should she be charged? So all we need to do is take the 50 and put it into this end of our flow diagram. So we have 50, we multiply it by 3 to get 150, then we're going to add 15 to give us £165 as our answer. So we put the 50 in at one end, multiplied by 3, added 15, and we got our cost of £165 out at the other end. Now, sometimes you can go in the opposite direction on a flow diagram when you're given the thing at the other end. So our challenge down here says, if her next bill is £126, how much electricity did she use? So the £126 is at this end. So we need to go back the way to work out how many units we've got. So we're going to be going in this direction. Now, if we go in this direction, we reverse what it is we did in these boxes. So instead of adding 15, we're going to subtract 15. Instead of multiplying by 3, we're going to divide by 3 when we come back the other way. So 126 take away 15 is 111. Then 111 divided by 3, well, I've got 111. I divide it by 3. 3 doesn't go into 1, carry the 1. 3 goes into 11, 3 times, 3 threes are 9, a remainder of 2. And 3 goes into 21, 7 times. So she used, on the challenge, 37 units. So can you see, if you're given something at the other end of a flow diagram, if you have to come back the other way, you reverse the function that's being carried out at each of the stages. Here's an exam style question with a challenge at the bottom to come back the other way to do the reverse calculation. So Ryan uses this rule to find out the speed in miles per hour. You take the number of kilometers an hour, you divide it by 8, you multiply it by 5, and it gives you the speed in miles per hour. So Ryan thinks 60 miles an hour is the same as 96 kilometers an hour. So all we need to do is stick the 96 at this end and see if we get 60 out at the other. So 96 divided by 8, well, if you can't do that, do it using the bus stop, is 12. And then 12 times 5 gives us 60 miles per hour. So to answer this exam question, is Ryan correct? Yes, he is. And the evidence for doing this is our calculations up there. Now, the challenge says, what is 130 miles an hour in kilometers an hour? So it's miles per hour. The 130 is at this end. So we have to go back the other way. So we need to divide by 5 and then multiply by 8. So let's do that. I've got 130 and I divide it by 5. 5 doesn't go into 1, 5 goes into 13 twice, remainder 3, and 5 goes into 30 6 times. So 130 divided by 5 gives us 26, and 26 multiplied by 8 will give us our speed in kilometers an hour. So 26 times 8, 8 twos are 16 with a 0, and 6 eights are 48. Add the two together, and we get 208 kilometers per hour. So what is 130 miles an hour? It's 208 kilometers per hour. And that was using the reverse flow diagram process. Here's another exam question to practice with. Have a go and see if you can also answer the challenge question on the bottom. So Layla's friend asks how to convert temperature from Celsius to Fahrenheit, and she uses this flow chart where you take the temperature in degrees C, you multiply it by 2, add 32, and you end up with the temperature in Fahrenheit. So let's do that. We have 31 as our temperature in C, and we need to multiply it by 2. So we end up with 62. We add 32, and we end up with 94 degrees F. So on the answer line, 94 degrees F is the answer worth 3 marks. Now, let's work out the challenge answer. So what is 54 degrees F in degrees C? So we've been given something at the right-hand end of our flow diagram, 54 degrees F. So we're going to come back the other way, and we need to do the opposite to get our degrees C. So I've got 54 and I need to subtract 32. So that is 22. 22 divided by 2 is 11. So 54 degrees F is 11 degrees C. And this completes the first of our learning outcomes. Next, we're going to do the level 2 learning outcome, where we evaluate an expression and make substitutions in given formulae. So let's have a look at this word algebra and define it. And it's a word you probably came across before in mathematics. Well, algebra is where we replace a number that we don't know with a letter until such time as we find it out. Okay, so this letter is sometimes referred to as a variable. So if we look at our previous formula from our level 1 section, where Sam's pay was equal to £5 times the number of hours, the next level on in mathematics for this is to replace these words for letters. So pay could be P, the £5 is just the number 5, times the number of hours, H. So what we're doing is we're swapping these long words for letters. Hours can be H. So his pay is equal to 5 times H. Now in mathematics, we can shorten this in algebra by getting rid of the multiply sign. So his pay could equal 5H. His pay is equal to 5 times the number of hours. And at some point, somebody will tell us what the number of hours are so we can swap h for a number like we did in the level 1 section. So algebra is the use of letters or symbols to represent numbers in maths problems. Basically, we don't know what numbers we've got, so we use a letter that represents those numbers until somebody tells us what they are. So in this example, the number of animals in the farmer's field is equal to the number of sheep plus the number of cows. Now, I have no idea how many sheep or cows there are until somebody tells me. Okay, so here, instead of writing the word animals, we have this variable a. Here we have sheep, s, and cows, c. So a equals s plus c. The a, the s, and the c stand for something, but we don't know what they are yet because nobody has told us. So the next part of the lesson is called substitution. This is where we swap the letters for numbers. So if I tell you that there are 10 sheep in the field and 12 cows, so we're swapping the letter S for the number 10 and the letter C for the number 12, then we know there are 22 animals in our field. So a formula is a way of describing a relationship or a rule. So it can be expressed in words, with the word equals, or in symbols. So here we have distance equals speed times time. So what we need to be told is what these letters stand for. So D equals distance, S equals speed, and T equals time. So I now have an idea of what I'm trying to work out, that my distance is equal to my speed. Don't forget what we said before. An S and a T stuck together means S times whatever T is. So what I'm saying is my distance is equal to my speed times my time. It's great to know that and understand more about the formula, but I can't do anything with this until you tell me a couple of the things that need to go in here so I can solve it. So if I tell you I'm traveling at 60 miles per hour and I drive for 3 hours, then I can do something with this. I know that my distance is equal to my speed, which is 60 miles an hour, times, because of that S and T being stuck together, and the number of hours is 3 hours. So the distance I cover is 60 times 3, which is 180 miles. So let's look at the type of questions you could get in the exam. Lots of words, a formula, but essentially what it's saying is, can you read this formula and can you swap the letter H and the letter D for the values that are in the text? So let's look at the question. The number of beans, B, in a tin of Heinz Baked Beans is estimated by the formula. B equals 9H plus 2D, where H is the height of the tin and D is the diameter of the tin. So how many beans would you expect to find in a tin that is 12 centimeters high and a diameter of 7 centimeters? So we know that the number of beans is equal to 9 next to the H means times H plus 2 times the diameter, D. And it's telling us in this text that the letter H is the value 12 and the letter D is the value 7. So we've done this substitution. We've swapped our letters for our numbers that then allows us to go on and solve this. Now remember the previous lesson on BIDMAS? We have to do the multiplications before we do the additions. So I know that 9 times 12, because I know my times tables, is 108. And then I'm going to add 2 times 7, which is 14. So the number of beans in my tin is 122. I add my 108 and my 14. So let's look at some more substitution, but this time having brackets in our formula. So here, this formula doesn't mean much to us because it's a letter and another couple of letters, and it could mean anything really. But actually, this is a formula for perimeter, where P equals the perimeter, L equals the length, and W is the width. So that's what these letters or variables stand for. P's perimeter, L's the length, W's the width. Again, I now understand what this formula is about, but I can't do much with it until you tell me what the length and width are so that I can work out the perimeter. If I tell you that the length of our rectangle is 6 centimeters and the width of our rectangle is 2 centimeters, I can swap the letter L for the number 6 and W for the number 2. So it becomes 2 brackets 6 plus 2 close brackets. Now remember BIDMAS? BIDMAS tells us to do what's in the brackets first, but don't forget the second thing, that there's a multiply between the 2 and the brackets. So it's 2 times what's in the brackets first, 6 plus 2, which is 8. So that gives us 16 centimeters as our perimeter. Let's have a go at a couple of functional skills type formula questions. So the formula on the right here is used to find the cost in pounds, including a deposit, of hiring some bikes. Jill wants to hire 4 bikes for 5 hours. How much will it cost? So a good starting point is to write our formula out in longhand. So we have the cost is equal to the number of bikes times brackets, so we've put in the multiply between there, 10 times the number of bikes plus 30. So basically we've expanded the things where we've got hidden multiply signs. Now we can swap the letters for the numbers that we've been given, so B and N. So it becomes B is 4 bikes times 10 times N is the number of hours, which is 5, and then add 30. Let's do this in parts. So inside the brackets, which we have to do first, we have a multiplication and an addition. So 10 times 5 is 50, has to be done first, and then we can add the 30. Now we can do what's inside the brackets. 4 times 50 plus 30, which is 80, and then multiply 80 by 4, and that gives us 320. So the cost is £320. Let's look at an exam question. Calculate the surface area of a cube when the length of a side is 5 centimeters. And the surface area is given to you as a formula where it's 6a squared, and we know that a is 5. So let's write this out in full. 6 next to the a means 6 times a, and we know that the letter a is the number 5, so it's 5 squared. So the surface area is 6 times, now don't forget BIDMAS, we do the index first, and 5 squared is 25. Remember our earlier lessons. So our surface area is 6 times 25. So if you can't do this off the top of your head, you can use your grid method. So 6 2s are 12, don't forget the 0, and 6 5s are 30. Add the two numbers together to get 150, and this would be centimeters squared. Sometimes in algebra, what we're looking for isn't neatly on one side of our formula. For example, here we've got 8 plus a equals 12. So what we're looking for is tied in with something else. It's not on its own. And to make it on its own, in maths we say we make it the subject. So I need to get a on its own to find the answer to the problem. Now, when you look at this first problem, 8 plus something equals 12, the something is going to be 4, because you know 8 plus 4 equals 12. But how do we do that mathematically? How do we show what's going on in your mind to solve this problem and harder problems that we're going to get later on? Well, we do it by creating the flow diagram for what's happening to our subject. So if we look at this first problem, I've got A, so this is the thing I'm interested in, and I'm adding 8 to it to get 12. So I've got A, I add 8, and it gives me 12. So just like our flow diagram, if we take the 12 and come back the other way, and we do the opposite, it gives us A, which is 4. 12 minus 8 gives us 4. And that's kind of what's going on in your mind. So let's practice this on a few examples. So for the next one down, I want to make B the subject. I'm looking for B. So let's tell the story of B. I've got B, and the first thing I do to B, 6 next to the B, means I'm multiplying it by 6. And it's giving me 24. So if I come back the other way, I take the 24, I divide by 6, I do the opposite, it tells me that B is 4. So 6 times 4 gives me the 24. B is equal to 4. Let's try something slightly more complicated again then. So we're looking for C in this case. So we take C, and the first thing that's happening to C is it's being multiplied by 3. So C is being multiplied by 3, and then whatever that is we're taking away 10, and it leaves us with 26. So we've got C, we multiply it by 3, we take away 10, and it gives us 26. So now when we come back the other way, 26, we add 10, which gives us 36, and then we divide by 3, so 36 divided by 3 is 12. It tells us that C is equal to 12. We can check it. 3 times 12 is 36, take away 10 gives us our 26. If you end up with these more complicated ones that you've got on the bottom, and they give you something where there's a variable that has a value, then all you need to do is do this first and then do the flow diagram method. So for example, you've got 4a plus, and then this means 3 times 2 when we substitute this value in. So 4a plus 6 equals 14. So do the substitution first and then create your flow diagram. So we want to make A the subject. So the first thing that's happening to A is it's being multiplied by 4. The next thing that happens to A is we add 6. And then finally, we end up with the answer of 14. So if we take 14 and come back the other way, we'll get the answer to what A is. So 14 take away 6 is 8. 8 divided by 4 is 2. So A is 2. We can put this in here. 4 times 2 is 8, and 8 plus 6 gives us our 14. Have a go at these and see if you can solve them. Okay, let's go through them then. So we're looking for D. So we've got our subject D. So what's happening to D? Well, we're taking away 5, and it's giving us the answer of 12. So when we come back the other way, I need to add 5. So D is 17. So D equals 17. So 17 take away 5 gives me my 12. Let's do the next one down. We're looking for E. So we're going to make E our subject. So we have E. We multiply it by 4, and it gives us 36. So if we start at this end with 36, we divide by 4, that gives us 9. So E is equal to 9. 4 times 9 gives me my 36. Let's look at the next one. So we're trying to solve f, so let's tell the story of what's happening to f. The first thing that happens to f is it's being multiplied by 2. Then we're adding 7 and it gives us our answer of 23. So f is being multiplied by 2, then we add 7 and we end up with 23. So let's come back the other way. 23 take away 7 is 16. 16 divided by 2 gives me f. So f equals 8. So 2 times 8 is 16. 16 plus 7 is 23. That's correct. And finally, where we have two variables, but one of them we're being given the value. So it's telling us solve g if h is 5. So do the substitution first. 2 times 5 is 10. So it becomes 6g minus 10 equals 14. And we need to solve it for g. So tell the story of g. The first thing we do to g is multiply it by 6. Then we subtract 10 and it gives us our answer of 14. So now when we come back the other way, we have 14. We need to add 10, which gives us 24. And then we need to divide by 6. So 24 divided by 6 is 4. So 6 times 4 is 24. Take away 10 is 14. So g is equal to 4. How did you get on with those? And this completes our second learning outcome, which is to evaluate expressions and make substitutions in given formula. There's more practice on Moodle on both of these outcomes, and also you'll be given homework and in-class worksheets to help you practice. Now let's look at the buzzwords for this video. One of the first words we came across was variable. And a variable is a letter representing a number. So until we know what the number is, we put a letter in there. So the word pay can be represented by the letter P. The word hour could be represented by the variable h. And until somebody tells me how many hours we've done, I can't work out my pay. And this is where formula comes in. The formula is a rule or relationship. So our pay is equal to £5 times the number of hours. So the variable P is pay, the variable h is hours. And if you tell me the number of hours, I can work out how much pay I'm getting, which is where substitution comes in. So substitution is where we swap the variable or the letter with a number. So if I tell you I worked 8 hours this week, so our formula is P 5H, where we times the number of hours, so £5 per hour, and I work for, let's say, 8 hours, it becomes the pay is equal to 5 times 8, which is £40. So my pay would be £40. And that's because we're substituting the number of hours I've given you, 8 hours, into our formula here. And they're the buzzwords for this lesson: the variable, the formula, and substitution. If you'd like any more information on these topics or would like more practice, then please go to Moodle or see your teacher. I hope you enjoyed this video.